LeetCode question at random and see how well I do. I'm going to talk through my entire process as if I were interviewing. I'll whiteboard some stuff out if I have to with my iPad, and I'm just going to see how it goes. I'm going to click pick one, and we're going to see how it goes. Oh, let me float my video at the top real quick. Okay. Maximum beauty of an array after applying operation. You're given a zero indexed array, nums, and a non-negative integer k. In one operation, you can do the following. Choose an index that hasn't been chosen from the range 0 to nums length -1. Replace nums index with any integer from the range. The beauty of the array is the length of the longest subsequence consisting of equal elements. Return the maximum possible beauty of the array nums after applying the operation any number of times. Note that you can apply the operation to each index only once. The subsequence of an array is a new array generated from the original array by deleting some elements, possibly none, without changing the order of the remaining elements. Let's look at the first example. First example, we've got 4, 6, 1, 2, k equals 2, output 3. In this example, we apply the following operations. Choose index 1, replace it with, index 1, replace it with 4. From range 4 to 8, nums 4, 4, 1, 2. Choose index 3, replace it with 4. Range 0, 4, nums 4, 4, 1. Okay, I'm gonna be honest. It's really difficult to comprehend this and read it out loud at the same time. Okay. I think I get the gist. So I need to either add or subtract k to get the longest length of a similar character. So in this case, because I can do 4, 4, 1, 4, the longest case, the longest length would be 3 because I have 3 4s. So 0, 1, and 3. To me, when I think of the idea of testing various scenarios to see all the outcomes that equals a certain thing, I think backtracking. And it's possible that this is a backtracking solution. So I'm going to have to draw out what this might look like. So let's do this really quickly. So if I start with 4, right? That's the first one. I've got 2. I've got 6. Next, I've got 2, and then 6 minus 2 is 4, and then 2, and then 6 plus 2 is 8. 2, 8. And then I've got 6, 4, and 6, 8. 4, 6, 8. So I guess there's a third. The third would be just keeping it, right? Just keeping it as one thing. So I guess the way to, hold on, let me erase the first part of this graph, because there's another scenario where we could just not do anything. So if I break this out, let's just have a third one here. This is all the same. This looks ugly, but I think you get the idea. 4. And we'll do the same thing here. I've got 4, 4, and then I've got 4, 8. And as we can see, as I'm drawing it out, we can see that this is going to be the one that is most efficient for us, and it's going to be the most frequent common number. So if I continue to go down, this will probably be the one that we need. So like this here would be the 6. This would be the 1. Then you would have really just the 1 scenario here, because 1 minus 2 is -1. We don't have any -1, so it'd be 4, 4, 3. And we break this out one more time. 4, 4, 3. And then if you were to add 2, that'd be 4. And that's ultimately our answer. So it would be a backtracking solution here. First step is create dictionary. And then I backtrack through values in the same way that you saw in the iPad. And then store values to dictionary. And then once I'm done storing the values to the dictionary, I take values and then add them to a heap. So add values to heap, and then get max from heap, and return max from heap as answer. And that should do it. Probably easier said than done trying to figure out the backtracking logic, but that's the gist. That's the gist of how it should work. So what I'm going to do, I need that dictionary value. I'm going to have a global variable. That's the dictionary value. That is going to be a dictionary with an int key and int value. I'm going to create my backtracking function. Backtracking. I'm going to pass a current index. I'll just call it I. I'm going to need nums. Obviously, I'm going to need nums and k, so I'll just copy this. And then I need really like a current dictionary. So I'll call this, or not current dictionary, current array. The current array, and then this will be an array of the integers for each scenario. So array event. Okay. So base case would probably be once I hit the current array max, like once I hit the length of nums, like once I is equal to nums length -1, then I should end the recursion. That'd be the base case. So if I is equal, or I would just say nums.count. So that might be it. If I is equal to nums.count, then stop. Then just return. And here we'll set. We'll probably. That's I guess at what point would I set the values to the dictionary? Because it's kind of like I would need like a dictionary for every scenario, because I need to know which scenario has the correct max. So I need a way to know. Dictionary might not work. I need a way to know what has the most common values. So I could do all that dictionary stuff here and then do the values thing and store max. But then I'd have to loop at the end of this. I'd have to loop through num, store it to the dictionary. Let's do that. Let's just do that. Even though it's going to be, maybe there's a more efficient way, but let's just do that for now. And then the global variable will be max. So max equals 0. Then I have the dictionary. I'll recurse through num. So for num in nums, I have dictionary num equals dictionary num plus 1. Now, probably need a default here for when it's empty to be 0. I guess the default probably doesn't really matter so much, but I do need the default. So the number that default is probably doesn't matter because it will get replaced by num. Then I'll take the values of the dictionary equals dictionary dot values. So that should give me an array. And then I will create a heap. Or yeah, I'll create a heap. And I will I'll say heap integer is dictionary values. And then I will get the max of that heap. And then I will say, and maybe I can say max result. And I will say max result equals the max of max result and heap dot max. And this is, I believe, is an optional, so I'll do that. So that way I'll do that operation for all of them, and then I will at the end return max result. So that should be good. Now I need to get through this. So I need my current array to be mutable. So I'll just do this. I will say current array. I need 3 different scenarios. I need the current number. I need the current number minus k, and I need the current number plus k. So maybe we start there. We'll start with the current number. Let me see. I need to call backtracking 3 different times. It needs to start with each of those. So let's do this. I will say backtracking, and I will say current array dot append. Okay, so I need to append. Okay, I need to append pop, append pop, append. So let's see. I'll add so it'll be current array. What do I call this? CURARR. Current array append nums I, which will start as 0. I'll pass current array to backtracking. So this would be I plus 1 because I want to go to the next value. This will, I'll pass back in nums, I'll pass back in I, or k, nums k, in current array, which is the updated value, current array. Now I will do current array dot pop last, and then I will append this plus k, and I'll pass it like that, and I'll literally copy this and do minus k. This can probably be broken out into another method, but hey, let's do this for now and see if it actually works. So, okay. I check, I have my base case. I append 4 recurse. Next scenario, I remove 4, and I append 6. Hit the recurse, and then I remove 6, and I append 2 in recurse. And now, if I call backtracking here, I think that'll work. That what I have there, by the way. Tracking, I'll have 0, nums, 0 because we're starting at the 0 index, nums, k, and empty array, because current array is going to start as an empty array. It's probably got to be, you know, instantiate the array. That should do it. I'm going to look through this a little bit again, because I think, let's see, if I don't think I'll be in a scenario where I'm going to crash from this, but we'll see. All right, let's go ahead and, no. I need to add it because it starts as, no, it should be fine because nums is, yeah, that should be okay. All right, let me run this and see what happens. Okay, compile error. What's happening here? Compile error. Optional to be unwrapped. Okay, got it. Okay. So line 24. So I'll just do this. 0. Crash. Okay. So I do need a check for that value that's there. So I will say if I is greater than nums.count minus 1, return. Is there anywhere else where I'm? Oh, well, I see something else here too. I put this inside of the brackets. I need to take it outside. It'll be plus k, and then this will be minus k. Cool. Let's try it again. Okay. Okay. So first case is wrong. Output 1, expected 3. Oh, and I'm using nums. I'm not using current array. That's probably the problem. Okay. Okay, I see. I see what's happening. So current array, nums, add this. Yeah. I think that's probably it. That's oh, whoops. That's probably what's happening. I used to tap and command save. That's what that's what that was. Okay. Let me run. Cool. All right, so we passed both test cases. Now hit submit. Oh, okay. So I got it wrong. Let's see if we can figure out what the issue is. Yeah, I'm perplexed. I'm confused with that one. So let me look at the problem statement again. Choose an index I that hasn't been chosen before from the range 0 to num's length. And then replace num with any integer in range minus k to plus k. Oh, replace it with any integer. So it can be anything in that range. So, okay. So literally, if I create this range, right, I have to iterate through every single one of those numbers. And then my same logic should work. Is just this backtracking method is going to get called a ton of times, depending on what k is. I just need to iterate through a range instead of doing this. And then each time I iterate through it, I have to do the pop last here that I have. So I have my range. So I'll say this equals nums minus k, parentheses, 2 plus k I will say for in range and I will take this and place it in here. Oops, I did not mean to collapse that. Take this, place it in here. And plus current range. And let me think about this for a second. Yeah, I do that. This would be +1. Pop last. And then do it again all the way through the entire thing. Yeah. So I think that's the modification I need to make to make it actually work. Or at least get through that that failing case. So let me run and see if this works. Okay. So I did the same issue where let me put this in here and then try again. Wrong answer. I have output 2, expected 3. Okay, I have range of current num minus k to current num plus k. Okay, so this should just be, no. Nums minus k, nums plus k. I iterate through, do I just pass this? Because I start with each, I start with 0, yeah. So I'll probably just pass this, and then, let's see. Okay, cool. Now I'll submit. Time limit exceeded. Okay, well that's at least, I think that's at least something that I can resolve. Okay. So it must purely be the fact that the iterations happen too many times in certain cases. But how do I prevent that? What is it I can do to speed this up to where it's actually gonna pass? Yeah. So that's it. That's the best I have with this one. I'll have to look through solutions and see what people did to make this go a little bit quicker, a little bit faster, to not get the time limit exceeded. But I guess the idea with this one is that backtracking will get you there to hit every scenario to be able to count the max occurrences where you can get the same common number, and that should be the way to do it. There's just something I'm missing here with efficiency, and maybe there is outside of backtracking, maybe there is there's a more efficient way to do it, but that's the best I've got today. It's been a pleasure, and I'll see y'all on the next video.